Welcome to all of you. Now we discuss a Regula-falsi method for solving a nonlinear equation, numerical practical 9. Regula-falsi method, that is the method of false position, is very old method for solving an equation. And in this method is the trial and error technique, and we use the false value, that is the test value, for the variable, and then adjusting the test variable according to the outcome. So this name is false position method. And this method here, we solve. In this method we choose 2 points, these points a0 and this point b0, and such that f a0 into f b0 is less than 0. Here this is the red curve is the function y is equal to fx, and this point a0, so this height is the f a0, and this point is b0, so this height is f b0. So f a0 into f b0, this is the positive height and this negative height, so obviously product of these two heights is less than 0. And then we choose a0 b0 is the initial interval that contains the exact root alpha. This is the point alpha, that the curve cuts the x-axis at this point alpha, exact root alpha. Now this the equation of the chord joining these points f a0 a0 comma f a0 and b0 comma f b0. So joining the chords, the equation of the chords is this: y minus f b0 equal to f b0 minus f a0 by b0 minus a0 into x minus b0. You can substitute this y minus f a0 by x minus a0 equal to f b0 minus f a0 by b0 minus a0. And this line cuts the x-axis at the point x1 x1 comma 0, x1 comma 0. So we put here x equal to this the x1 or ck here, and this y equal to 0. Then we calculate the value of ck, and that is equal to bk minus fbk into bk minus ak by fbk minus fak. If we put here ak, then the this form is simply changed. This the ck equal to ak minus fak into bk minus ak by fbk minus fak. So this is the point. This is the point ck, intersecting point with this x-axis and the line joining these two points. Now we find the value of f f f a0 and f x1. We call it this a0 point. This point is b0. We call it this point x1. So f a0 into f x1 is negative. Then we write this new a1, this point a0, and new b1, and this point is this. So this is the point a1 and this is the point b1, this point. Else this if fx1 and fb0, fx1 into fb0 is negative, and then write a1 equal to x1 and b1 equal to b0, and then the root alpha lies between this a1 and b1. And again we draw the line joining these 2 points, and this is the a2 is the uh, second approximation to the root of this. And this is the Regula-falsi method. And the now came to the C programming for Regula-falsi method. Problem 9. Write a C program to find the smallest positive root of the following equation by Regula-falsi method, correct to 5 decimal places. X plus ln x whole divided by ln bracket 10 plus r by 10 bracket close plus x into e to the power x equal to 5, where r is the last digit of your C roll number. Here, first we define the function fx. This is the function f, float f. Arguments are float x and integer r. So this is the x plus log x. Actually, this log means in C programming base e. That is the natural logarithm. Whole divided by log uh, bracket 10 plus r by 10 plus x into e to the power x minus 5. Main program. This is the integer main. Float variables are a, b, x1, x2, h. Error term, that is 1 into 10 to the power minus 8, that is 0.701, that is 100000001. Integer value variable r, last digit of your roll number, and n is the step counter. First we enter the value of r by scanf percentage d ampersand r. Next, print enter the initial interval endpoints of the boundary points of the initial interval ab that contains the exact root alpha of the equation fx equals to 0. And this the scanf is percentage a ampersand a and ampersand b. Here the initial steps are equal to 0. Now if fa and into a b greater than 0, so we change the initial interval AB and go to the step calculation. So come back to the step calculation. Again re-enter the endpoints of the initial interval AB. Else, that is means else means if A, that is means if A into AB is less than 0, then we going forward. And now this step length h, this h here, this b minus a into a absolute value of fa whole divided by absolute value of fa plus absolute value of fb. Because fa and fb are of opposite signs, so in this formula we get this minus of this. This is the this h is this. If we put here ak, and this is the put ak bracket bk minus ak by fbk minus fak. So this is the h, and fbk ak are opposite signs because this negative product is negative. So you can use the alternative form of h. This is equal to minus b minus a bracket into fa whole divided by fb minus fa. You can use the alternate form of the h, and this h is the x1 is the new value, a new approximation. This is equal to a plus h. Now if fa and fx1 is negative, then b equal to x1, b equal to x1. Else, that is fa into fx1 is greater than 0, then greater than 0, then a equal to x1, a equal to x1. Now x2 is the equal to x1, and h equal to b minus a into absolute value of fa whole divided by absolute value of a plus absolute value of fb, and x1 equal to a plus h. And increment of the step n plus plus, that is n equal to n plus 1, and this do while loop going to up until absolute value of x2 minus x1 is greater than error term. That is error term is the 5 decimal places. So here we choose the error term is the point 0.000001.1. That is the 0.701, because we want to the exact value of the up to 5 decimal places. So this is the root of this x1 is the root. Now we save this program and then compile, and run this program. Enter the value of r. We put n equal to r equal to 9, then the initial position say 0 and this 1. Here display shows that change the initial interval AB and again re-enter the endpoints of the interval AB. Choose A equal to 1 and B equal to 2. We get a table, this the value, this the column n, step counter an, bn, fan, fbn, h, xn plus 1, f x1 is this, and this the table, the root is this 1.25236 correct up to 5 decimal places. Now if we find the Desmos app graphing calculator, this function is this x plus ln x whole divided by ln 10 plus r by 10 plus x into the power x minus 5.0. This is the fx equals to 0, and this is the r. You can change this r from 0, 1, 2, and this stabilizing the integer from 0 to 9. If we choose r equal to 9, and this the function graph, this the root that cuts the x-axis at the point 1.252 comma 0. So alpha equal to 1.252 from the Desmos app when r equal to 9. And from the C programming we get this 1.25236 is the correct to 5 decimal places from the C programming. So both are almost same. And this completes the lecture. Thank you for watching this video, and all C file and Word file are given in the description box. Thank you again.